I'm audible.
Yes, Sheetal.
And my screen is visible.
Yeah, it's visible.
Yeah. So, good afternoon to everyone. This is
Yeah, good
Sheetal Kumari.
afternoon.
Yeah, this is Sheetal Kumari from MIT University, India. And this is my topic, optimization and modeling by response surface methodology using triticum aestivum biomass for methylene blue. Now, the introduction part is the one of the world major issue today is the massive pollution released into the environment due to the rapidly expanding industrials and the agriculture operations. So, right now, more than 70,000 to 1 lakh dyes are reportedly created each year from a very variety of industrial process, and these are the including maybe plastics. Textiles, food processing, and other pigments industries also included. So there are many types of dyes. It may be a cationic, maybe anionic, and maybe a non-anionic dyes. And these dyes are very harmful for the aquatic as well as human beings also. So these the dye disposal into the environment is a detrimental effect, and the effect can take a shape of a cosmetic problem such as water that is discolored and smell bad, as well as the death of aquatic ecosystem is also reduce these side sunlight penetrations and decrease the DO level. So in the study I used a methylene blue dye for the removal of the waste dyes from the wastewater, and using adsorbent that is triticum aestivum. And there are many treatments, there are many wastewater treatments using in the world, and but the I used adsorptions process that is a very cost effective and easy process, easy treatment for the removal of the dyes from the wastewater. But there are many drawbacks of this process. There may be substantial chemical requirements like mobility, metals mobility, costly. But in case of adsorption, it is very low cost and very easy to use treatment method. So this is the process of the bioabsorptions process. This is the bioabsorber. Maybe you can remove a dye, heavy metals, and metalloids also. So these are the some boundaries of the adsorbent. These are the functional group maybe attacking on the adsorbents, and there are maybe interactions each between pollutants and sorbents. So the interactions may be electrostatic interactions, maybe anion exchange, maybe precipitations, maybe hydrogen bonding, and maybe enzymatic mechanism and redox mechanism also takes place. So these are the mechanism involved in the adsorption process. So this is in this study I used a triticum aestivum that is a result of a wheat harvesting, and it is a very significant carbohydrate source also. And there is a technique we used in the treatment process, that is your RSM modeling, that is response surface modeling. This is the very ideal operating condition for a system to build a model. And in this modeling we can use different parameters like your there are 4 parameters used, that is temperature and dose concentrations, and dose concentration, temperatures, and some some pH also included. And this is the RSM process. First, we prepare a stock solution with the different concentration. After the incubator shaker, put into the incubator shaker for 1 hour, and the result may be visible in your screen. So this is very effective, around 99% removal results are coming out from this process. So these are the independent variables, and you can say a parameter which is used in this my study, that is adsorbent dose, dye concentration, dye solution, and the temperature. And this is the optimization study, and so in this table you can see around maximum 92%, 93% removal, 92%, 93% dye removal with the help of triticum sativa. So these are the 3D graphs, and these parameters are their parameter is very play a important role in this study. So this is these in if the dye concentration increase, then removal may be decreased, but the we have increases the adsorbent dose, then the dye removal is also increases. So this is the role of the all the parameters. And we can also done isotherms and kinetic study also. There are two. These are the isotherms, Langueur isotherms and Freundlich isotherm. But in this study, we have conclude that say the pseudo second order is a good fit as compared to other pseudo first order. And in the thermodynamic study, we have conclude that we have concluded that the thermodynamics process for the bioabsorptions on the triticum extremum is provide a very good value, a significant value for the bioabsorption process. So the optimal projected MB removal is 94%, which is very close to the actual value, that is 95.1%. And this is the parameter, that is 39.9 is your concentration, and 6.9 is your pH, and contact time is your 60 minutes at the 30°C temperature. So we can say a very good combination and very good connections between the independent variables and the bioabsorptions of the methylene fluid. Basically, bioabsorption process is a depend on the pore size of the adsorbent. So this graph is the show a zero, the R square, the coefficient, the correlation coefficient shows a 0.9216 R square value. So that is a good combination and provided very good connections between the actual and predicted values of this study. So this is their isotherms analysis. So the isotherm analysis, in there are two isotherms used. That first is your Langueur isotherm and second is your
analysis.
But in this study, Langueur isotherms, the isotherm in this study, the Langueur model shows a very they show the bioabsorptions of methylene blue is homogeneous, and dimonal is a major layer to covered by the adsorbent. So I already told the pseudo second order is binding mechanism provided the best result for this dye or adsorb on the triticum sativum adsorbent. So this is the thermodynamics. This is a very exothermic nature for this reactions. And so we also at the end of the conclusion is the optimization is frequently used to remove the efficiency of the methylene blue dye for the removal percentage. And I think the efficacies of this study is predict the performance of the MB dye removal and the interactions of the efficient independent variables like dose, dye concentrations, pH, temperatures created by using a RSM modeling, that is response surface modeling, and achieve a maximum dye removal. And pseudo second order is best match for this experiment. And Friendling model was less accurate as compared to Langmuir model. This is conclude. And for the thermodynamic study, there is endothermic, spontaneous, and practical nature for the bioabsorption process is show the thermodynamic parameter, including the Gibbs free energy, enthalpy, and the entropy. So we also says that the triticum astrium is a very less tried and easily accessible and practical solution, and a very cost-effective solution for the removal of dye for the textile industry, according to the finding of my current study. And this is the reference in when I have published a one paper related to this study in a Nature scientific report in 2023. So thank you.